Hello, you are welcome to Physics with Umoru. Here on the board we have a JAMB question, JAMB 1988, sorry. And it says a tap supplies water at 25 degrees Celsius while another supplies water at 75 degrees Celsius. If a man wishes to bathe with water at 40 degrees Celsius, find the ratio of the mass of the cold water to the mass of the hot water. We have option A, 1:3, option B, 15:8, option C, 7:3, and option D, 3:1. So to solve questions like this, especially when it comes to questions from the topic heat energy, that is the specific heat capacity and heat capacity, one thing you should always note is that heat gained is always equal to heat lost. So here is a story, a case of a tap that can supply hot water and cold water. So the water at 25 degrees should be the cold, since 75 degrees is the hot. So if a man wishes to bathe with 40 degrees Celsius, it means that the man will have to mix the hot and the cold together so that the person can actualize 40 degrees Celsius, which is the warm temperature. Okay, so let me use Q as heat. Heat gained is equal to heat lost. So here, when they are mixed, you notice that the hot water becomes warm finally, and the cold water becomes warm finally. You notice that the cold water gained heat because it gained from cold to warm, and the hot water lost heat from being hot to being warm. Okay, so heat gained should be the heat gained by cold. Let me call it the cold, C for cold, that is the water. And heat lost is the heat being lost by the hot. Generally, heat gained or lost can do so many things on a body. Number one is changing the temperature, and number two can be changing the states. So we have to check what happened by the end of this mixture. Did it change in the temperature or in its state? So if you look here, you notice that after mixing, the man wishes to bathe with water at 40 degrees Celsius. So which means that temperature will have to change from 25 to 40 and from 75 to 40. So the heat gained here and heat lost here will cause a change in temperature. And heat that causes a change in temperature, this is the formula. Q is equal to MC. This C is the specific heat capacity. I had to use CP to differentiate this from the heat capacity itself. So mass times specific heat capacity times change in temperature. Okay, so let us list out the parameters here. A tap supplies water at 25 degrees Celsius. So it means that theta for cold is 25 degrees Celsius, while another supplies water at 75 degrees Celsius, which means temperature for hot is 75 degrees Celsius. If a man wishes to bathe with water at 40, which means let this be the equilibrium temperature or the temperature of the mixture, that is the warm temperature after mixing, theta is equal to 40 degrees Celsius. Now the question is, we should find the ratio of mass of cold water to the mass of hot water, which means ratio of A is to B means A over B. So ratio of mass of cold to mass of hot is going to be mass of cold over mass of hot. This is what we are looking for. Okay, so to continue, remember the heat that will change temperature, this is the formula. So which means I will make this specific for the cold and make it specific for the hot. So heat gained by the cold water, the formula will now be mass of cold, that is using this formula, times specific capacity of cold times change in temperature of cold should be equal to heat lost by the hot water will be mass of hot times specific heat capacity of hot times change in temperature of hot. Now you notice something about specific heat capacity. Since both the cold one and the hot one, they are all water. So water has a constant specific heat capacity. So the specific heat capacity of water is 4,200 joule per kilogram per Kelvin, or 4.2 gram per joule per gram per Kelvin. So because the hot water and the cold water, they have the same specific heat capacity, so we can cancel out this because they have equal specific heat capacity. Now we are now left with mass of cold times change in temperature of cold is equal to mass of hot times change in temperature of hot. Okay, now change in temperature. Remember that for the cold, changed from being cold to warm, that is from 25 to 40. So the change in temperature here will now be mass of cold will be mass of cold times 40 minus 25 is equal to mass of hot. The change in temperature, the hot from being hot at 75 to warm 40. So the change in temperature there is going to be 75 minus 40. 75 minus 40. So when we do this, we are going to have mass of cold times 40 minus 25 is going to give us 15 is equal to 75 minus 40 is going to give us 35. Okay, 35. So mass of hot times 35. Now to finish this up, remember they said we should find the mass of cold over the mass of hot. So since I have the mass of hot, this is how you solve this kind of question. Since you have the mass of hot as the denominator, so you are going to divide both sides by the mass of hot. Anyone you have down, just divide through by 8, so that I will have mass of cold over mass of hot on one side of this expression. So M cold times 15, I will divide through by what? MH. So we have MH. I might decide to make it specific to this. This is something as writing all over MH, but I just want to separate this. Okay, so divided by MH again, so that here mass of hot will cancel out mass of hot. We now have 15 times mass of cold over mass of hot is equal to 35. So I want to make this subject of formula, which is what they asked us to find, the ratio of mass of cold to mass of hot. So when I do this, I'm going to divide both sides by the coefficient of this ratio. So we'll have divide through by 15, that will be divided by 15, divided by 15. This will cancel out. We are now left with mass of cold over mass of hot is equal to, something can go here, 5 can go into this, we'll have 7, and 5 can go into this, we'll have 3. So we now have 7 over 3. So 7 over 3, which is same as 7:3. So 7:3. So this makes the C the answer. Bye-bye.